So 11 a lens with a greater curvature. And I'll put in brackets there then thicker. Okay, has a higher optical power. Now, thinner lenses don't change the direction of light rays as much. So they have a lower optical power, and obviously vice versa. Thicker lenses do change the direction more, so they have a higher optical power. And that then leads to the formula. So the formula, the P stands for optical power. And that's measured in diopters, or just capital D for short. F is the focal length, but it's got to be in meters. So you'll see when we do the worked examples, we'll do some conversion. So if you've got it in centimeters, it's got to be converted to meters. It's a 1 at the top. Right. So P equals 1 over F. It's called the inverse. Now, the other thing that we need to indicate, an optician would need to indicate, is which type of lens. We've been concentrating mostly on convex or converging lenses, right? But an optician can also indicate whether you need a converging or diverging lens by using a plus sign for converging and a minus sign for diverging. So positive power for converging lenses, negative power for diverging lenses. And then we'll do some examples. Oh no, actually, see, just before I go into that, I'm going to write this. I think this is quite a difficult formula to rearrange. So I'm just going to write in a second box beside the first one the rearranged form of it. It's a 1. Okay? Now, I don't know how to do it to make it clear it's a 1. Is that clearer? Yeah, it's a 1. So if we take the lens we were just looking at, it had a focal length of 5 centimeters. What would be its optical power? Right. Negative and positive. So plus VE for positive, minus VE for negative. Right. So we're right, the focal length is 5 centimeters. But notice over in the units part beside F, I said it's got to be in meters. So you have to convert that. Yeah. Divide by 0.05. Okay. Now in some ways this is an easy formula because there's only ever one thing you've got to put into it. It's not like V equals IR. You don't need a current and a resistance and so on. So the formula is P equals 1 over F. Substitute in then P equals 1 over 0.05. If you do that in your calculator, then you'll get the answer of 20 diopters. Example 2 then, a lens has a power of minus 5 diopters. Calculates focal length and state what type of lens it is. Okay, so in this example we know that the power is 5 diopters. When I'm doing the calculation, I don't put the minus sign in. Right, once we've got an answer, we'll consider what the minus sign means. So the power in this example is 5 diopters. The focal length is what we're being asked.
Is it minus 5 then?
It's minus 5, but I say we don't put the minus in the calculation. Right, so the formula is F equals 1 divided by P, which in this example is 1 divided by 5. So F is 0.2 and the unit would be meters then, that's the standard unit.
1 divided by, is not 1 divided by 5?
No, 5 divided by 1 is 5. 1 divided by 5 is 0.2. And then lastly we'll use the minus sign to state the type of lens. The minus sign tells us that this is a diverging lens.